Get them now. First thing off the top, any questions, issues, concerns, problems, anything else before we get started today on the math? Anybody? Okay. Sounds like, well, a few people have your mics open, which is usually okay, but there's some noise in the background on one of them. So it's okay. That seemed to no, there's still some. But anyway, all right. There was an announcement. It came in late yesterday. I saw it this morning, and I posted it this morning, probably after y'all had already checked. Most of you had checked your announcements. So you might want to go back and check if you're interested. Okay. It's from the NASA Community College Aerospace Scholars Program. We've had several students from Lawson participate with it in the past. They've always enjoyed it immensely. It's a lot of fun. They're having to do it all virtual now, but maybe by the time your program's over, you can actually get to go to have the possibility of going to NASA, at Huntsville or one of the other locations and participating more hands-on. Oops, here comes Ivan. Let me get him in here. If I can just find my cursor, there it is. Okay, Ivan's here. All right, that really rounds out the top of the alphabet. They're coming in very strongly today. Okay. Um, so they sent it late yesterday, so I posted it this morning, and I tried to post it. I did post it to all 7 classes I'm teaching this first mini term. Okay, 6 of them are full term, 1 of them's a mini term class. And I got them all posted, and then as soon as I finished that, I went to delete the email that came in, and there was an email they sent this morning and said, whoops, we forgot to do something. So I was starting to try to post the additional information they put out there, and I only got the first 2 classes done, yours and the pre-calculus trig. I don't know when I'm going to have time to do the others, but I'll try to do them sometime. The trouble is they sent the email yesterday, and then they corrected it this morning for an event that's happening this evening. I believe it's either 6 to 7 o'clock or 7 to 8 o'clock. I think it's 7 to 8. So go look at the emails. One's entitled NASA Community College Aerospace Scholars. That's the long title. And the next one I just put NCAS as the abbreviation for it, because I just didn't have time to type all the other stuff, and I was trying, and that's one reason I was a minute or 2 late getting Zoom started. Of course, Zoom was slow getting started. Evidently, it's having problems again. I mean, I think all the infrastructure is having problems. For instance, yesterday, Zoom would not open my 3rd class. It opened the first 2 perfectly fine. It would not connect to my 3rd class. And it said, check your internet. 5 bars. There was no problem with the internet. Do you have a whatever they call it, a block or something like that? No, I just taught 2 classes on Zoom. There was no blocks in the way. But it would not load. I tried. Yes. Was there a question? I tried twice. Okay, and nothing happened. It would sit there saying connecting, 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 and then say cannot connect. Check your bank. So I finally had to take down everything that I had, including my Screencast-O-Matic, unfortunately. Okay, and it was still loading my previous class. So when I then brought everything back up, well, now this is something that I've noticed several times Zoom has screwed up like that. Almost always Microsoft is trying to do an update, and I think they interfere with each other. So anyway, when I shut the system down, I had to wait till Microsoft did its update, and then I brought it back up again, and even then it was slow connecting the first time. The second time it finally did connect. I finally was able to get in the class, but then when I started the recording, the Well, actually, it may have been Screencast-O-Matic's fault. I started the recording okay, and it seemed to be all the classes were there. Um, but then my memory filled up. This new computer they gave me, it's about 2 years old, issued me. It has very, very low memory space, and the memory filled up, so I had to clear out some stuff and start back again. And that time, Screencast-O-Matic had thrown away everything else. So I got most of the classes had loaded to Blackboard. My previous class had not, so they're gonna miss that class. But I have it recorded out there on um, from the summer, so they'll be okay. But sometimes this kind of stuff happens. I just want to let you know. Zoom sometimes, Screencast-O-Matic sometimes, they all are running into difficulties. All right, do you have any issues, concerns, problems? That was my sad, sad story. You heard the violin music in the background. Okay. Anything? I have a question. This is Janae. Yeah. Did they say anything to you about the financial aid, like when we're going to get our Pell or whatever? No, did you? I can answer that. I called them the other day and I was asking them when they're going to reimburse the check. They said that it's they basically don't know you. They basically what? They haven't determined a date yet that they were going to do that. Well, when I called the other day, I called and I also inquired about that too. They said that they're doing it every Thursday. Yeah, that's what the calendar said. The lady told me, she was just like, it's 30 times. I mean, when are you going to reimburse the check? She was just like, well, it hasn't been determined yet. Yeah. I do know this, and this is all I know. They were having enormous problems with this new system, banner system, and the financial aid. They thought they had everything. They'd been going to classes and training and all like this for months and months and months. The financial aid people, the administrative people, the academic people, all of them had been going, and they thought they had everything done, but the system didn't work. So I know the dean canceled a meeting. Yay! I'm sorry, I didn't say that. One last Friday, saying they had to work on the financial aid stuff and that we'd have to make it up later. And so they were working all weekend on it, I think. Well, wait, this may have been the previous Friday. It was the last Friday in August, and they were going to be working all weekend on it. So, yeah, I guess that was, I don't know, whenever it was, because the day's the 10th. So that would have been the previous Friday. And evidently, they still are having problems. Now, I know that's not a very encouraging answer, but that's probably why some of you are getting different information. They probably are able to cut some checks. And this, this new system is so squirrely. For instance, the people who came this summer, we were on the old system in the summer. We entered the grades on the old system. And then when it came to this fall, some people's grades came over and some people's grades did not. I have a woman in one of my other classes. She took Calculus 2 this summer. And then when she went to register for Calculus 3, it said she couldn't do it because she didn't have the prerequisite. So she was afraid she wouldn't be able to do it, so she registered for Calculus 2 again and was planning to do a drop add. And all during drop add week, it kept telling her, nope, she didn't have the prerequisite. No, she didn't have the prerequisite. Finally, I talked with the, when I found out sort of what was going on, I talked with the registrar next time I was able to catch her, and she said, oh, that's been happening all over the place, we'll have to do it. And she did a special case for her. So I bet you it's the same thing with, or something similar with financial aid. Some stuff may have gone through okay and some stuff didn't. So that's why they're cutting checks every Thursday. As they pick up more students, they do the check. So I would say, just like these other students have, did you try to do that FINAID at lawsonstate.edu? Did you email them, and what did? I talked to the lady that's over financial aid for Lawson State. Right. I think her name is Miss Collins. And she basically said the same thing, that they don't. It's the new system or whatever. However, I feel like that has nothing to do with us students. Like, we still have stuff for school that we need, and we're a month into school, and Yeah, it's believe me, they're panicking about it probably as much as you are almost, because they have federal guidelines saying they have to pay you within a certain length of time. So I know they are stressing when I read that email from the dean, and she has nothing directly to do with that, but they were just trying to figure out how in the world to get this thing to work. So I know they realize your situation, but they are hamstrung by the fact that this new system is so stinking awkward. Okay, it it is has the craziest thing. Well, part of it is a 2-year college system. That's our fault too, not our school necessarily, but our the system fault. This is just a silly example, but it is. You know how they said you have to do something that first week of class or you'll get removed from the roll permanently. Okay? So I was that first weekend, any student who had not responded, either been to class or submitted something, I was calling them from all 7 classes, calling and emailing and trying to get in touch with the students to make sure they knew they had to do something that first week before they shut things down that Sunday evening. And then later they said they relaxed that. Well, okay, give me a break. I spent my whole weekend doing that. But still, that was the deal they said. Now, here's how we had to handle it. This sounds so stupid, and it felt so idiotic. How we had to enter attendance because this new system doesn't have a mechanism for putting attendance in. The old system did, this system doesn't. So what we had to do was go to final grades on the My Lawson. We had to go to the final grades and enter the last day of attendance as your first day of attendance. And if you had a day of attendance there, then you stayed in the system. If you didn't, you got kicked out. And that was absolutely ludicrous that we had to go to final grades, last day of attendance, and put in a first date of attendance, even though it said last date of attendance, and then that would keep you in the course. I thought, can anything be stupider than this? So it's not at all surprising that a lot of these systems just aren't working well. Uh, the state's the one that decided we would go to this term. Okay, so don't know. I wish I could help. I really do, but I know the people there are literally pulling their hair out. And you see, if I already pulled mine out. No, I'm just kidding. Okay. Was there something else? I see, Brianna, your mic's still on. Do you have something else to add? Okay. All right. Any other issues, concerns, problems? Sorry, I didn't have any good answer for that one. But
Well, yeah, I do. I have a question. Well, it's a question, but it's a concern. I'm still waiting for my financial aid situation to be taken care of for your class. So, in the event that something is not caught in time and your class is dropped, well, what do I do? Because my financial aid thing keeps saying unsatisfied when I've turned in my information. And that has nothing to do with you, but it's just something that I do want to bring to your attention in the event that it doesn't happen.
okay, now your case may be a bit rare, and I hate to. If you have been talking to someone and they're okay with it, that's fine. But a lot of times, financial aid will not kick in if you're only taking 3 hours, and I think that's all you are. I know you're making up 2 classes from the summer when you were sick, but that doesn't count for fall. So you're going to need to talk with the people in the financial aid office to see if you are even going to get that, because I'm almost certain you have to have at least 6 hours. But they may have relaxed that because of circumstances, but I can't. I don't know. I do not know with yours, because we've talked before and I found out this is the only class you're technically registered for fall term. You're making up 2 more, I understand that, but those were summer classes, not fall classes. So you better check with financial services and see if you're even going to get. Maybe you've done all the paperwork, but if you're not got 3 hours, I'm not sure they're going to pay for 3 hours. I can't answer that. I don't know what their rules are. I don't know what the exceptions are. I don't know any of that, but that's something you ought to check on. Okay? Like I said, it probably isn't good news, but I know in the past I've heard that before, but they don't have us messing with financial aid, but I do pick up and hear things, and that's one of the things I've heard before. So you might want to check on that. All right, any others? Any other issues, concerns, problems before we get going today? All right, let me see if Zoom will pick up. And yesterday I had a hard time, Zoom had a hard time picking up. There it is, it did get it. Okay. Yesterday I fought in 2 of my classes to get it to pick up the PowerPoints, but it's doing it now. So we'll go with current slide, if I can get this to respond. And I know you think I'm messing around. I'm not. There is a taskbar that sits, Zoom puts it right in the field that you're trying to read. So I've moved it out of the way, and Briantra, you're in the way too. I've got to scoot you a little to the right. Okay, no, it's all of your names. Okay, now, can everyone see difference quotients, the PowerPoint? Yay or nay? Anybody? Yeah, good. All right, good deal. All right, we're still in Chapter 1, Functions and their Graphs, in Section 1.4. Hopefully we'll finish this today and get into 1.5. We're on page 42, the bottom of the page, and this is difference quotients. Okay? Now, that may be a term that you haven't heard before, but guess what? It's a concept you're very familiar with. It's just a different name. Okay? And well, I can't get the PowerPoint to advance. Okay, here we go. One of the basic definitions in calculus, and this is pre-calculus algebra, employs the ratio f of x plus h minus f of x divided by h, as long as h is not equal to 0, of course. Now you may look at that and say, nope, never seen anything like that in my life. Was that your first impression? Think again. Now, I don't know if you recall, I told you what the most important thing to remember in pre-calculus about functions. What is f of x? Very simple concept. What is equal to f of x? Or f of x is equal to what? Let's see if I can make one. I can't make one. Y is equal to f of x. Remember I said that? Remember that. One of the most important concepts going. So, x is your independent variable on the horizontal axis, and h is just a little bit of number, a very small increment you're adding to h. Okay? So here's one h here, and the second h is here. The one x here, x plus h is here. Okay? Now, this is f of x plus h. So go from this value on the x-axis, find your f of x plus h. That's y at x plus h, right? Minus y at x. That's a change of y, isn't it? Okay? Now, I'm going to throw something else at you. So the top part here is basically a change in y. Have I convinced everybody that's true? This is a y value at x plus h minus the y value at x. Okay? X plus h is here, x is here, y here, and y there. That's the change of y. Okay? Now, remember what I said the two x values were. X plus h minus x. This one minus that. That is your change in x. But look at this. X minus X is 0. That leaves you H. So your H is your change of X. Now, does that ring a bell? What is change of Y over change of X? Anybody recall? Slope, exactly. Y'all know this, okay? A difference quotient is just another expression of a slope. Change of Y, which is your F values, over the change of X, which is your change of X values. That's all it is. That ratio is called a difference quotient, and we're going to deal with it in example 11. Now, remember what your functions are telling you to do. Hang on to that. So here's example 11. For f of x equal to x squared minus 4x plus 7, and this is at the top of page 43 if you're following in your book, find that difference quotient. Okay. Now, obviously, the first thing you need to fill this in is to figure out what f of x plus h is. F of x plus h. Remember how we do that? Everywhere you see an x up here, you put an x plus h in here. So that would be x plus h squared minus 4 times x plus h plus 7. So that's going to be, this is going to be this first term up here. So let's do the math. Okay, I'm going to try to come over here so I can do it. Does anyone remember the easy way to square a binomial? If not, we'll do it the longer way. Anyone remember the easy way? I'm guessing not. So let's do it the longer way. Okay, what does x plus h squared mean? Let's do it over here. X plus h squared. What does that mean? It means you take x plus h and multiply it by x plus h. That's what it means to square something. Multiply it by itself, right? Now, that looks like something we remember from algebra, how we multiply binomials. Foil them. Curses, foiled again. X times x is x squared. Then the outer, that's the first. Outer is plus xh, or I'm going to put it, that's supposed to be a plus there. It's a pretty ugly looking plus. Plus xh, and then the inner is another plus xh, and then finally the last is plus h squared. Okay, now I've run out of room down here, but you see what you got as your answer here is x squared, and you have two xh's or hx's, whichever you want to say it, it doesn't matter to me, plus 2hx, and then you got a plus h squared. That's what the product of a square of a binomial is. Now that's the long way. Here's the short way. Okay? Square the first term, x squared. Okay? Does anyone know what that was about? I had a ding in my ear. Let's see if anyone else is trying to come in. No, it doesn't look like it. Okay. So, square the first term, x squared, if the pen would write, twice the product of these two, plus 2xh, or hx, it doesn't matter which order you do them, and then square the last term, plus h squared. And that's exactly what we got here. Okay? hx, xh, it doesn't matter. To me, did you have something, or your light just come on? Okay. All right, so that's the first one. Minus, this one we're just going to distribute, minus 4x minus 4h. Don't forget those minus signs. They're only there to trip you up. Don't let them do it. Keep up with them. And then you got a plus 7. All right, we just got a little bit more to go here, just removing those parentheses. X squared plus 2xh plus h squared minus 4x minus 4h plus 7. Wow, that's this part right here. Now we know what f of x is. There it is right there. Okay, so let's fill in the blank here. Now I need a lot of room to write, so I'm going to come down here to do it. So I'm going to sort of break this off. So this will be this expression here. That's your f of x plus h right there. So let me write it down here. X squared minus 2xh. This is lots of letters. Okay, that's a plus. How did you let me get away with saying a minus there? Okay. Plus h squared minus 4x minus 4h plus 7. All right, there's that one. Now we're going to subtract this term. Now subtracting this is going to change the sign of every term here. So this is going, and if you need an extra step, by all means write it in. Put a minus sign, put this thing in parentheses. If I wasn't so cramped for room here, I would do it that way, but let's just do it here. Let's just change the sign of every one of that. That's what the minus sign here does. So that's going to be a, if I can find my cursor here, minus x squared plus 4x minus 7. That's your numerator. This part is the f of x plus h. This part is the f of x negated. That's what the minus sign did. And all of that divided by h. Now, that looks pretty messy, right? Unless you notice, here you have an x squared, and here you have a minus x squared. Here you have a minus 4x, here you have a plus 4x. All these are adding to 0. Here you have a plus 7, there you have a minus 7. That adds to 0. So what do we have left? We have left 2xh plus h squared minus 4h. That's all that's left in the numerator. In the denominator, of course, you still have your h. But looky here. Every term in the numerator has at least one h in it. So let's factor that h out. Okay? That leaves a 2x in the first term, a plus h in the second term, and a minus 4 in the third term. Divided by h, but guess what? H over h is 1. So here is your difference quotient. 2x, whoa, someone's trying to come in. Let me see if I can catch them. Diana is here. Okay, let me get Diana here. It looks like we also lost somebody. I don't know who that was, but we picked up Diana now. So let me find her. There she is. All right. Helps the bottom part of the alphabet start catching up. Top part was just going crazy getting people here. That was good. And let me say this too. I did get a few things updated and changed in Blackboard. You probably won't even notice that I did. I'm still not where I need to be, but I made some progress yesterday. I finally had a day without too many interruptions. Now, of course, that means I probably hadn't checked my emails to see if there were more interruptions, but I just said, look, let me just work on this. So let me see if I can get the pen to come back. There it is. 2x plus h minus 4. That is your difference quotient. That's what this thing is here, is this right here. Where did the h go? I said it, but it didn't write. Okay. 2x plus h minus 4. Okay. That's your difference quotient. And if you look in the book, that's exactly what they got. 2x plus h minus 4. Yeah. Now, they hang on to this. The h cannot equal to 0. But guess what? What does it matter now? Because it's no longer in your denominator. Now, if you're interested in what, and by the way, Diana and any others that came in a little late are in the middle of this, we're on page 43, chapter 1, functions of the graph, 1.4 functions, just doing example 11 on this new concept called a difference quotient. I am recording, so if you did miss some of this, you can go back and pick it up first part of class on the recording. Now, the bad news is that it won't be out there until sometime late today. It'll be on YouTube in time, but I've got classes stacked one after another, so it'll be after my 5:45 class, the last class is finally over, that I'll be able to, sometime after that, upload things to the playlist. So after that, you'll be able to see it. Okay, now. All right, somebody else is coming in. Weston, I think it is. So let me admit Weston. Okay, not sure that's what he goes by. Yes, he does. Weston Golston. Okay, so he's here. Excellent. Okay. So Weston, if you can hear us, we're in chapter 1, functions in the graph, section 1.4, functions. We just been talking about what a difference quotient is. Listen to the first part of the class on the YouTube video when it gets out there sometime late this evening, and you'll hear how we're doing this and see what we've done to get here. And this is on page 43, example 11. Let's see how they do it. Okay? I don't know if somebody else is behind that window or not. Let me see if anyone else is waiting. I don't think so. No. Okay. All right. Let's see if we can. It won't advance until I click on the screen. Okay. So I know this is behind there. Okay. Here's what we do. F of x plus h minus f of x over h. That's what we got here. Well, this first part, f of x plus h, you put everywhere you see an x up here, you put an x plus h here. So this is x plus h squared minus 4 times x plus h plus 7, and then subtract from that this expression, x squared minus 4x plus 7, sorry. Okay, all divided by h. Okay, soon we'll be out of my writing so you can see this a little bit better. So here's what this gives you. Squaring this, you get x squared plus 2xh plus h squared, that's that part, minus 4x minus 4h, watch those minus signs, plus 7, and then you negate everything inside the parentheses, minus x squared, minus a minus is plus 4x, and minus a plus is minus 7. All divided by h. But at that point, you notice, I don't think they show you this, they just make it disappear. I'll go on and show it to you. This, where is there? This x squared gets canceled out with, or adds to 0 with that x squared. This minus 4x here adds to 0 with this plus 4x. This plus 7 here adds to minus 7 to become 0. So you're left with 2xh plus h squared minus 4h, and that's all, folks, over h. But notice that you can factor out an h from every term here. There's an h, there's an h, and there's an h. Factor it out. That leaves you 2x from here, 1h from here, and minus 4 from there. Divide that by h, but at this point you can divide out the h's. Here you added the pluses and minuses to get the 0. Here you divided the h's to get the 1. Okay, so there is your difference quotient, 4x plus h minus 4, as long as h is not equal to 0. Now I was going to tell you this. Here's what they do in calculus. They do a process, they say take a limit. Now, of course, h can't be 0, but h can get very, very close to 0. Okay, now if you have a slope up here like this, and you get your h very, very close to 0, what you wind up is not a slope of the line between 2 points, you get the slope of the tangent line. As h goes to 0, you get the slope of the tangent line, which is what we call a first derivative. Okay? And if h is approaching 0, I'm using my finger here, this is going to 0, so your slope is 2x minus 4. So whatever your x value is, plug it in. That gives you the slope at that point of your curve. You don't need to know that part, but that's where it's heading as a difference quotient. Are any of you planning, I hope some of you are, to continue and go to calculus? Of course, you got to do pre-calculus trig first and then go on to calculus. Any of you engineering majors, physics majors, math majors, you'll be going on. This is the kind of thing you'll do. You'll let h approach 0, even though it can't equal 0, and as it does, this approaches 2x minus 4. Okay. You don't need to know that, but that's just why they do difference quotients. Now, by the way, I say this often, I'm going to keep saying it. After every example in the text, there was example 11, right after that is a checkpoint. And it says audio video solutions for the checkpoints are available at larsonprecalculus.com, an absolutely free website. And there's the problem. Very similar to the one we just did. An excellent thing to do as soon as you can after class is over with. Do the checkpoints. Those answers are in the back of the book too, so you don't even need to go to larsonprecalculus.com unless you can't get that answer. Then go there and you can see the audio video solutions for that checkpoint. All right, now here's a summary of function terminology. First, what in the world is a function? Function is a relationship between two variables such that to each value of your independent variable there is one and only one value of your dependent variable. Okay, it's maps on here. This one goes to one value there. Function notation, as I said before, I think just about the most important thing you can remember in pre-calculus algebra is this one little phrase right here. We hit it today. I can't find my pen. There it is. Y is equal to f of x. If you remember that, you've got most of this knocked. Now, what do we mean? F is the name of the function. Okay, I don't really like that terminology, but that's what this book uses. Y is the dependent variable because it depends on what x you put in here. X is completely independent. Pick a value anywhere in the domain of the function, any value in the domain, pick a value and you'll get the y. Okay, because you use the function to operate on the x and give you the y. So y depends on x. So y is the dependent variable, x is the independent variable. F of x is the value of the function at x. F of x plus h was the value of the function at x plus h. You just put x plus h everywhere you saw an x. You put 7 everywhere you put it, I mean, whatever. That's the value of the function at whatever you put in the parentheses. The domain of a function, set of all the values, the inputs that independent variable x could take on, okay, for which that function is defined. Now, we'll come back in a moment and talk about this, what it's defined. If x is in the domain of f, then f is said to be defined at that value x. If x is not in the domain, then f is said to be undefined at that value x. Now, where are some of the obvious places that x may not be defined? Well, it wasn't an x, it wasn't domain, but it was something we saw in that difference quotient. A denominator can never be 0, ever be 0. Okay, so if you have x in your denominator, whatever that expression with x is in the denominator, that expression can't be 0. X could be 0 unless the x is there by itself, or 2x or something like that. But if it's x plus 3, x could be 0 because the denominator can be 3. But x couldn't be minus 3 because that would make the denominator 0. So that's what we mean by being defined, for which the function is defined. It cannot lead to something that you can't do. The other thing to watch out for is variables under a square root or any even root. Most of the time it's going to be square roots, okay? Because guess what? You cannot take the square root or any even root of a negative number. You could take the square root of 0, that's 0. But you can't take the square root of -1 or -3 or negative pi or negative anything. You have to have a positive value under there. So that excludes those values from your domain. Now, what is the range? The range of a function is a set of all values of the outputs assumed by the dependent variable, which in our case was y here, that is the functional values. Everything the function could take on. Now, always we assume your domain is all real numbers unless you hit some of those for which it's not defined, okay? Like makes the denominator 0 or make the argument of a square root negative. Those kinds of things you have to exclude. The range, however, depends on that function. For instance, a squaring function does like this. The range never goes negative because you square a positive number, it's positive. Square a negative number, it's positive. Square any number and it's never negative. So therefore your range may only be positive values. And you have other circumstances like that. So the range depends on what the function is doing. Now, what I was talking about before is your implied domain. If f is defined by an algebraic expression and the domain is not specified, the implied domain consists of, our first assumption, all real numbers as long as you don't have a variable in the denominator that would make that denominator go to 0, or you don't have a variable inside a square root which would make that try to take the square root of a negative number. That's your implied domain. All real numbers for which that expression is defined. In other words, that fit the function. Okay. And I do believe that is the last slide of the section. Wow. Okay. Now, there is vocabulary at the top of page 44. Let's hit that. 4 questions, fill in the blank. If you got your book, it's on page 44. If you don't have your book, listen carefully. Okay? And some of this you just heard me say. A relation that assigns to each element x from a set of inputs, or what is the set of inputs called? Blank. We just hit it. Set of inputs. Domain. Excellent. Exactly, a relation that assigns to each element x from a set of inputs, or a domain, that's the first blank, exactly one element y in the set of outputs, which is the range, perfect, okay, is a blank. A function, excellent, okay. A little visual help there, okay. You probably knew that anyway. Number 2, for an equation that represents y as a function of x, the set of all values taken on by the blank variable x. What's the other name for the blank variable x? Independent variable. You're really good at this, okay? And the set of all values taken on by the blank variable y. Okay, I didn't finish this. The set of all values taken on by the blank variable x is the domain, and the set of all the values taken on by the blank variable y is the range. What is the name for the y variable? Dependent variable. Excellent. Number 3. if the domain of a function f is not given, then the set of the values of the independent variable for which the expression is defined is the blank blank. If it's not given a specific domain, what do we assume? Implied domain. Excellent. Okay. Number 4. One of the basic definitions in calculus uses the ratio f of x plus h minus f of x all over h. As long as h is not 0, that ratio is a blank blank. Not on the slide. Is a what? Difference quotient. Y'all are really quick. Okay, good deal. All right, here's the homework exercises in 1.4. You've heard most of these before. We added just a few more this time. Either 5 or 7. Remember, all the answers are in the back of the book, but not just that. If you can't get that answer in the back of the book, the odd numbers are all at calcchat.com for tutorial help and worked out solutions for the odd number exercises. So do either 5 or 7. They're both at CalcChat. 7, because it's got a red letter there, it's also at CalcView. And that CalcView, you actually have an interactive version of working that example. So do either 5 or 7, both at CalcChat, 7's at CalcView. Do number 9, it's at CalcChat. Do any of the odds 11 through 17, they're all at CalcChat, 11's at CalcView. Do any of the odds 19 to 29, they're all at CalcChat, 21's at CalcView. Do either 31 or 37, they're both at CalcChat. Do either or any of the odds 35 to 41, they're all at CalcChat, 37's at CalcView. Either 43 or 45, they're both at CalcChat, 43's at CalcView. Either 47 or 49, they're both at CalcChat. I'm sorry. Any of the odds 47 to 55, they're all at CalcChat, 49's at CalcView. Then do any of the odds 57 through 71, I believe it is, yes. Oh, I think someone else is trying to come in. Let's see if they are. I can see someone's up. Oh, there it is. Oh, Shay is coming in. Yep, let me get her. All right, good deal. Shay, welcome. I don't know if you can hear me yet, but we're just finished 1.4. I was given the homework exercises. That last group I said was any of the odds from 57 to 71. They're all at CalcChat, okay, if you need that help there. Then, here are the new ones that we did today. Any of the odds 73 to 79, they're all at CalcChat. 75's at CalcView. Either 81 or 83, they're both at CalcChat. And then there's a couple true false, 85 or 87, they should be at CalcChat. And then there's one error analysis. I really don't like this because it sort of makes it seem like they say it's wrong, the big red X there, but I still hate for them to write something in the book that's wrong, you know. See if you can find out what makes it wrong. If you want to do that, you can. That's 89, and you can think about doing either 91 or 93. That's up to you. All right, any questions on 1.4? And it looks like she's still trying to get in. Maybe this thing is in the way here, so I'm sorry, Shay. I thought I had let you in, but they put a box over it, and I thought I had clicked the box, and evidently it didn't click. But I've marked you here already. Sorry that I didn't get you in time. Okay, but hope you didn't wait too long. Any questions? 1.4. All right, then let's Again, this thing is so aggravating. I have to click the screen before it will advance. Okay, that's the end of the slideshow for 1.4. Finally, we're done. Okay, let's move on to 1.5. Okay. Oh, Janae must have had to go out and come back in. I hope I've got her back in. She's joining now. And let me see if I can get the screen to share again. We're not through today, folks. Okay, I thought I saw people leaving. What's? I'm sorry. Oh, that's all right. Glad you're here. Okay, you'll probably have to listen to the YouTube video, which unfortunately won't be posted until late this evening because I'm in class all day today until 5:45, and then sometime after that I'll get the courses moved over to the playlist and YouTube videos. But you can watch it there, and before then you can watch same class that I did last spring. It should be there. Okay, I'll just look for 1.4, and there's several of them out there. Okay, and here it's gone and done the same thing it did before. I have the PowerPoint open. In fact, I think there it is right there. I think that's it right there. No, it isn't. There it is. Now, let's see if I can get Zoom to open it. Whoops, not hit the wrong key. Okay. Sorry this takes too long to do. Alright. I think this is so aggravating. There's so many steps you have to go through. What I'm going to have to do is close this and then open it again. And there it is this time. What a pain in the neck, or some other body part. Okay, here's the slideshow from current slide. And again, my taskbar is right across the bottom part of the screen, not the bottom part, but near the bottom middle part of the screen, square in my way. Okay, so now I've got that moved. Functions in the graph, chapter 1. Now we're going, now it won't advance till I click on the screen. Okay, 1.5, analyzing the graphs of functions. Now, you may not have realized this yet, but you're going to see it from now on. This author, and most authors these days, they love doing graphs. So that's what this section is talking about, looking at the graphs, analyzing the graphs of functions. Okay? And boy, do we have some objectives here. We'll first use the vertical line test for functions. Maybe some of you are already familiar with that. We will find zeros of functions, and we'll use graphs to help us do that. We'll determine intervals on which the functions are increasing or decreasing. We'll use graphs to help us do that. We'll determine relative maximum values or relative minimum values. We'll use graphs to do that. We'll find the average rate of change of a function. Now that may sound like something new, but guess what? It isn't. In fact, it's something you just did with a different name. And then finally, we'll identify some even and odd functions, and more importantly, some neither functions, because functions don't have to be either even or odd. Many functions are neither even nor odd. So I wish they'd have put that in there. All right, so let's first look at the graph of a function. We did a little bit of this in 1.4 at the very beginning when we said you can put ordered pairs, you can put a table, you can describe it verbally, you can write an equation, you can do all these things, but one of the ways you could express a function is graphically, a pictorial, okay? So we have studied functions from an algebraic point of view, mostly so far. In this section, we'll study graphs from a graphical, we'll study functions from a graphical perspective. The graph of a function, f, is a collection of ordered pairs. What is f of x? Someone tell me? Told y'all to remember this. What's f of x? Y. X, y pairs. Hey, there it is again. xy, x f of x. That's saying the same thing. Such that x is in the domain of f. As long as x is a legitimate value to plug in, you can do it. There it is. Okay. So as you study this section, remember that x is the directed distance from the y-axis, how far you are from the y-axis, whereas the y is how far you are above or below the x-axis. If x is positive, it's to the right. If x is negative, it's to the left. If y is positive, it's on the way up. If it's negative, it's somewhere below the x-axis. Okay? So this function, at least for the portion of it, the domain that they show here is always positive in y. They don't have to be, but they are. At this point right here, this is the point x, f of x. F of x is awfully close to 2. The x, I don't know, maybe about 1.3 or something like that. But it doesn't matter what it is. That point represents an ordered pair, an xy pair, or an x f of x pair. That point represents that one thing. Here's another one there, there's another one there, another one there, there, all along there. This is a continuous function. You have an infinite number of ordered pairs, even between 0 and 1. An infinite number in between there. So infinite number anywhere right around there. It's just amazing how many points you have there. So that's what we mean by the graph of a function. Put in an x, figure out where you are on the x-axis, find the value up here on the y, there you have that point on the graph. So here's example 1. Use this graph here, shown in this figure 134, to find first what's the domain of f. Someone tell me, remind me, what is the domain of a function? Anybody? What is the domain of the function? All the acceptable what values? X values, okay? Now this function here, you see, the first x that has a value is over here, and that appears to be at -1. And it includes -1. So in set notation, we would say the domain was -1, and then everything to the right of that until you get to 5, but you don't include 5 because you have an open circle there. But you write down 5, but then what symbol do you put here? Yeah, but close it with a parentheses. The bracket means you include the -1. The parentheses means you don't include the 5. So it's everything from -1, including -1, up to 5, but not including 5. So there's the domain of that function. So that's the first one. Now if you write it in set notation, that would be the set of all x's, because the domain is the x's, such that -1 is less than or equal to x, and x is less than 5. No equal sign there because this is an open circle here. And then you close your brace. Set of all real numbers within those bounds. It could be -1 or anything to the right up until you get to 5, but it can't be 5. Now, the second question here is, what's the function value of f of -1? What is f of -1? What is f of something? It's always the what value? Y value. And what's the y value when x is -1? What's the y value? 1. There it is. That's equal to 1. What is f of 2?
-3.
Excellent. Look at that. Okay. -3. There's the b part. How about the range of y? What values of y can this function take on within its domain? No. Y values.
Okay, the Y value is still on the
What's the smallest Y value it can have?
-3.
-3, but it includes that. So this will be bracket, -3, and it can go up to 3, and it includes 3. So then we would put 3 with a bracket. Now if we express that in set notation, that's the set of all, because this is a range, that's the set of all Y values such that -3 is less than or equal to, that's what the bracket means, Y is less than or equal to 3. That's expressed in set notation. This is in interval notation. For the domain, there's a set notation. Here's the interval notation. Does that make sense? And do you understand how we got the F values here for x equal -1, y is 1. X equal 2, y is -3. You see the ordered pairs right there. -1, 1, 2, -3. That gives it away. Any questions on that? Okay, let's see how they answer it. The closed dot at -1, 1 indicates x equal -1 is in the domain, whereas the open dot at 5, 2 indicates 5 is not in the domain, but it goes right up against 5, but doesn't touch 5. So there's in words. So the domain is, and put they like interval notation, bracket, because it does include the -1, -1, comma, 5, but not including 5. So that's why the parentheses there. Everything in between. Okay? Make sense? Because -1, 1 was one of the points there, it follows that f of -1 has to be 1, because when x is -1, y is 1. And x goes here, the independent variable goes here, the dependent variable goes there, 1. And because 2, -3 was a point there, then when x is 2, f of x, which is y, is -3. Make sense? Okay. And finally, because the graph does not extend below f of 2, and there it's -3, or above f of 0, which happened to be +3, but it does hit both of those, the range is just the interval from -3 to 3, inclusive, square brackets, including the endpoints. Any questions? Is that my phone? Okay, I've got a friend calling. I'll call her later. Okay. It rings, it rings, it rings. Okay. The use of dots, whether they're open or closed, at the extreme left or right points indicates that the graph does not extend beyond those points. Now, if that graph had extended beyond there, and you see the graph going on down here, we assume it goes on indefinitely. Okay? But if they stop right there and don't, we indicate it stops